Hi friends, today we are going to see finite state machine. So what is finite state machine, and then what are the types of machine, how to represent it, right? So first of all, if you know, finite state machine is something called a finite state automaton as well. It is a computational model that can be implemented with the hardware and the software. It can be used to simulate sequential logic and some computer programs. Finite set machine can be used to model programs in many different fields, including mathematics, artificial intelligence, game, and linguistics. Let's see the definition of a finite state machine, how to define it. It is a model of computation based on hypothetical machine made up of one or more states. Obviously, that should be finite. That's why it is called as a finite state machine. Only one single state of a machine can be active at the same time. This is important thing. We are moving from state to state, accepting starting state to the accepting state, and at the one time machine is in the single state. It means machine has to do the transition from one state to another to perform the different actions. That means it is different for different problems, right? Every language have different machine, so every state transition diagrams are different. Now let's see important points about that. We have fixed set of state the machine can be in. Very first point, that means differentiate states. Then machine can only be in one state at a time, as I already told you. A sequence of input is sent to the machine. A sequence may be binary sequence, may be any alphabet set. We have to define the input set. Every state has a set of transitions, and every transition is associated with input and which is pointing to the state. So why it is used? What are the application of finite state machine can be used in the real world application? So there are so many examples. I took here two only. For example, coin operated turnstile. Here, what are the states? Whether it is locked or unlocked, only two states are there. And when it will do the transition, that means what is if I am in the locked state, then how to go to the unlock, what is action, what is input I am supposed to give it. Pointing a coin in a slot will unlock the turnstile. Pushing the arm of the unlocked turnstile will let the consumer pass and lock the turnstile again. So this is how it works. Now let's say another example, traffic lights. So what are the states here? Traffic lights are three: yellow, red, green. We know that. The transitions will be after a given time. There is a time period, right? Red will change to the green. Green will change to the yellow. Yellow will change to the red accordingly, right? So if you are in one state, which will be the next state? It is based on the time. So such more examples are there where we are using the finite state machine. So for automaton, as I said, automata, this is a subject of theory of computation, which or we can say here we are studying the different math models. That is what automaton. So what are the automaton? Finite automata, push down automata, and Turing machine. First of all, we will focus on the finite automata here, right? So finite automata, what are again the type? There are two types, deterministic and non-deterministic finite automata, which is based on the we can say number of states. If a particular state I am present, then where to go to the next state, whether so there may be multiple options in the non-deterministic finite automata, whereas I am sure about what is the next state. There exists only one state in the deterministic finite automata. We already studied that and we know that, right? So only based on the which automaton provides output, based on that there are two types: finite automata with output and without output. Whatever we discuss right now, deterministic and non-deterministic, or along with the epsilon, all this belongs to the without output. They are not generating any output. They are just acceptor or the rejector. Whereas Mealy and Murray, these are the two machines which gives me the output and input. So first we'll see the Mealy machine. Mealy machine is defined. What is Mealy machine? Now let's say the definition. It is a machine theory of computation whose output is determined by both the current state and current input. So here it is very important. This machine, this is FSM, which gives us output, and here output depends on the state as well as input. I need to consider both the things. And it is defined as a math model, or it is a tuple of 6 elements. Q, capital Q I say, which is nothing but a finite set of state. Q0 is the initial state. Alpha or sigma, sorry, this is a sigma. It is the input alphabet set. Or here sometime we can use the delta. In the next few slide, I will change the symbol to show the some books uses this capital O, sometimes uses the delta, right? And this is a transition. This is what output alphabet, because we want output at a particular state, right? So what is the output related to that state? And this is a transition function. At a particular state, after reading some input, what will be the next state? This is represented like this in the maths, right? And this is a lambda. Lambda is the output function which means what? At a particular state, after reading some input, what is the output? See the difference between the lambda and the delta. Delta is a transition, right? So it will give me the state. What is the new state? And lambda is the output function. So it will give me the what is output. So let's see with the example. This is not exact example or the problem statement, just for your understanding how to show it, how to represent it. This is the transition matrix and this is the transition diagram. So how to draw the transition matrix and how to draw the transition. This is how it looks, right? See, from this observation, excuse me, don't bother about what is the problem statement. Then this is a transition graph for what problem statement. We'll see later on how to design or how to generate the Mealy machine. First of all, see, this is a one state, arrow pointing to the state. That means this is the initial state. On reading input 0, I'm switching the state to B. On reading 0 on the B, I remain in the same state. On reading 1, I am going to the another state. So likewise, we are doing the transition graph. At a particular state, for input 0, input 1. Every deterministic, right, way we are searching for that. How I come to know? I will refer this chart. This is what is your present state. How many states are there? A, B, C, D. Actually, it is not visible here. It is A, B, C, D. Right, based on that, we can identify. Just a minute. We will use review so that I can use it here to point for better understanding. So see, at a particular input A, this is initial state, right? So this is A. So on reading input 0, what is the state? B. What is the output on the state? It is x1. So it is related with this. You can write it here, x1. Now at a B, what is after reading input 0, I'm in the same state, right? And the output related with that, it is x2. So you can write here x2. Then similarly on reading at a state B, on reading input 1, what is the state? It is D. So this is state D. And output associated with that is at a state B, after reading 1, the output is x3. So you can point out here as x3. Similarly, we can continue at a state D. After reaching the D on reading 0, now see here 0, here 0, I am at a state 3. So it is written like this, 0 oblique x3. Why we are doing so? Because this is Mealy machine, and in Mealy machine the output is related with state and the input, right? So this is what Mealy machine, right? And this is what, this is AB, so obviously it is state C, and at a C, where is the C? This. On input 0, I will go to the D, and my state will be or output will be x3. So you are supposed to write here x3. Now next one, on reading 1 at a C, I will be in the C only, and output associated with x1. And on I think we left with the one A. On reading 1, we will go to the C, and output associated with the x1. So this is what final Mealy machine, right? So this is how we will see one more example, right? Designing. Now I just show you how to how Mealy machine looks like, but here here we'll see one more example how to design a Mealy machine that accepts the language consisting of a string from alphabet set, where alphabet set may be 0 or 1. It may be anything, right? In this example it is 0 1, and ending with the double zeros and the ones. So this is one example. Now we'll see how to draw the Mealy machine, right? Or design the Mealy machine. So here what is input set? What will be the output? Ending with the double zeros and double ones. So output is either 0 or 1. But that means actually double 0 and double 1. Means what is the alpha set of that? It is obviously 0 or 1. Or whether it is belongs to what you want to say. We have to check, just check whether the whatever the string given is ending with double zeros and double 1. If it is so, then output will be the yes. Otherwise output will be no. Now, so O set will be Y or N. What is the initial state? Q0. On reading now, input 0. I am at a Q0. So after reading input 0 at a very first time, I may read either 0 or 1. Suppose I read 0, machine take transition to new state, that is called as a P0, which looks for the next consecutive 0 to get the double 0. Similarly, on reading 1, machine transits to another state, say P1. P0 is to remember 0 and 1 for remembering number of ones, right? Here we seen just 1 1, right, which looks for the second consecutive one to get the double ones, right? So once we get that, we have to give the output yes, otherwise output will be no. So let's see the example, or what is the output here? See, so if I at Q0 is my start state, on reading 0, I go to the P0. That is just 1 I have read. Then on 1, I will go to the P1. This is just seeing first state. Now next consecutive, what may be after reading 0, if I get one more 0, then and then I will say yes. And we have to think for the positive cases only. So this is giving me output yes, otherwise no. So here, if my string starts with 1, very first time I see 1, I will hope for the next one. If I get one more 1, then I will say yes, accept. Otherwise, any number of ones we will get, still that string contain the double ones. So we will achieve the object. Now, as this is a deterministic automata or it is a finite automata, we have to consider for the what is the if I go get here first 0, second 0, and now I get 1. What to do? that string still accepted, right? So we will go for the next consecutive ones in the